So number 67, we have a metal sphere of radius 15 centimeters that has a net charge of 3 times 10 to the minus 8 coulombs, is kind of drawn below. A, what's the electric field at the sphere's surface? Well, to find that, we really should find the electric field outside of this sphere. And if we use Gauss's law, we know that the surface area of our Gaussian surface outside of this is just going to be 4 pi r squared equals the charge inside over epsilon naught. In this case, very quickly, the charge inside is simply the Q, and I'm going to leave this as a general expression first, and we'll plug in our specific values in a second. Plugging in our specific values, at the surface of the sphere, 0.15 meters, we'll discover that the electric field is 12,000 newtons per coulomb. Part B now asks, if we set V equals 0 and infinity, which is sort of the standard, what is the electric potential at the sphere's surface? Well, if you remember, to find electric potential, we just take the negative integral of electric field dot ds. In this case, our limits are from infinity to r, where r is some distance away from the center. And we're plugging in the electric field. Please notice that I've changed the r squared to s squared because I'm integrating with respect to s. The integral of this, most of you are pretty comfortable with. Everything in here is a constant except the 1 over s squared. Taking the integral of that becomes negative 1 over s, which the negative here cancels out with a negative in front, and we just end up with this. Plugging in infinity as one of our limits, as s approaches infinity, the expression approaches 0. And so I think most of you are comfortable at this point realizing, oh, electric potential is just going to be this. Finally, plugging in our numbers to find the electric potential at the surface of the sphere. Charge is given, radius is given, and if you solve this, you'll discover the potential at the surface of the sphere is 1800 volts. Part C. At what distance from the sphere's surface has the electrical potential decreased by 500 volts? It was at 1800. We just need to figure out, hey, when is the potential 500 volts less than that, or 1300 volts? In this case, we're solving for R. And if you solve it real quick, you'll discover that distance is 0.21 meters. And I don't know specifically what you're asking it, but it's about 6 centimeters, 0.06 meters from the edge of the thing. I think the answer they're looking for here is simply 0.21 meters or 21 centimeters. Hopefully that helps.